And now back to limits. You're going to use lhopitals rule. We don't know what that means, but let's go limit. So first step with limits, plug it in. So the limit as x goes to negative 2, cube root 2 times negative 2 plus 3. So that's negative 4 plus 1 is, negative 4 plus 3 is negative 1. Cube root of that is negative 1. And this one, limit as x goes to negative 1 of 1 plus 2 is 3. Square root of 3. Ooh, how about this limit? All right. This is a fraction. So what I'm going to do with this one is I'm going to do the top and the bottom individually. Because if they go to dangerous places, then I don't know what's going on. 3 squared minus 7 times 3 plus 12. So that's 21, that's 21, so that's 0. Actually, I'm doing top and bottom individually because if you write 0 over 0, that's mathematically inaccurate. And that gets, I'm pausing because I messed this up. I'll fix it. That gets you in trouble. So I got 0 there. I should not have put this in yet because I still wrote the limit. But I got 0 on top and 0 on bottom. So that's a problem. And so what we would do, what y'all have done, is factor. So you'd factor the top. That's x minus 4, x minus 3, x minus 3. If you're struggling with factoring, make sure you talk to me. I can teach you. It's like magic. For some reason, that 3 won't come out correctly. Cross those out and plug in 3, and I get negative 1. So don't tell me the limit doesn't exist. Tell me that the limit is negative 1. Okay, let's consider one that the book talks about. X squared over 2 to the x minus 1. So the limit as x goes to 0 of x squared is 0. The limit of as x goes to 0 of 2 to the x minus 1. So the limit as x goes to 0 of x squared equals 0. And the limit as x goes to 0 of 2 to the x minus 1 is also 0. So here's what's going on. Down below, these are the graphs. You see how these become lines over time? And it appears that this one's like always 0, and this one's not. They're getting closer, but they're getting closer and closer. Those slopes are important. Sorry, I forgot what I was talking about. The slopes are super important. They will help tell me what the limit is. So that's why I zoomed in here, because I could look at what the slopes are. So what L'Hopital's rule tells me is I want to look at slopes. So if I look at the slope of the top, the derivative of the top, and the derivative of the bottom, which I could do work for you, but I'm just going to tell you what the derivative of the bottom is. 2 to the x natural log of 2. And I can try again. Well, I would still get 0 on top and 0 on bottom. No, I wouldn't get 0 on bottom. So I get 2. I got tricked there. So I would get 0 on top, and then I get natural log of 2 on the bottom. So that limit would be 0, which makes sense based on the slopes I'm looking at here, where the quadratic is on top, and the exponential, which looks kind of linear, it looks like it's 0 over something non-zero. So that's what's going on with my limit here. Hence why we're looking at derivatives. And that's what L'Hopital's rule tells us. If we get something of the form 0 over 0, or infinity over infinity, to be fair, then we can take the derivative of the top and the derivative of the bottom, and we get the same answer. Don't believe me? Think back to that previous one. Oh, I didn't look at it. I think it was this one, though, right? That was plus 12, right? So 7x. There we go. Now, we already showed that you get 0 on top and 0 on the bottom. Don't write 0 over 0 because that's bad. So I could use L'Hopital's in order to justify lhopitals, I have to show this. So make sure you show that. You could also get infinity, but usually on the questions we're asked on the test, we get 0 over 0. We could in the book have kind of some more fancy things, because I try in the book to go farther. And then that was 2x minus 7, so 2 times 3 is 6 minus 7 is negative 1. And look at that. That's the same answer we had on the previous page. And let's try one more. One more time. So I have to show the limit of the top. And the limit of the bottom. And since I get 0 and 0, I can take the derivative of the top and the derivative of the bottom. The derivative of the sine is the cosine. And then the derivative of 5x is 5. Derivative of the sine is the cosine. Now plug in 0. Those are both 1, so I get 5. Which, if you put sine of 5x and the sine of x into Desmos and you zoom in, the sine of x, the slope will look like 1. The sine of 5x, the slope will look like 5. Hence why we're getting 5 over 1, which is 5. And that's all I wrote.